let's have a look at question 11. Figure 5 shows a sketch of part of the curve C with equation y equal to 8x squared e to the power negative 3x. And then the finite region I is bounded by the curve C, the line with equation x equal to 1 and the x-axis. So we want to find the exact area and leave in this form. Okay, so it's just integration. Let's have a look. So 8x squared e to the power negative 3x dx, the limit is between 1 and 0. And then because there's a product, so we definitely need to use the integration by parts. So I will let u to be 8x squared and then differentiate. So du over dx is equal to 6x. And then dv over dx equal to e to the power negative 3x. Then integrate that. V is equal to e to the power negative 3x over negative 3. So then that will give us, so times u and v will be negative 8 over 3x squared e to the power negative 3x, and then minus the integral of v and then du over dx, which is negative 16 over 3x e to the power negative 3x dx. And then the limit is 1 and 0. So I will simplify this a little bit more. So negative 8 over 3x squared e to the power negative 3x. And then negative make it positive, so plus 16 over 3, and integral x e to the power negative 3x dx. And then with the same limits, 1, 0. So because there's still a product here, so we need to use another integration by parts. So u equal to x, and then du over dx equal to 1. And then dv over dx equal to e to the power negative 3x. So that means integrate that v equal to e to the power negative 3x over negative 3. So that's what give us negative 8 over 3x squared e to the power negative 3x plus 16 over 3. I will put a big brackets. So u times by v will be negative x over 3 e to the power negative 3x. And then minus the integral v and du over dx. So anything times 1 is the same. It's just e to the power negative 3x over negative 3 dx. And then with the same limits, 1, 0. So that can be simplified to negative 8 over 3x squared e to the power negative 3x plus 16 over 3 negative x over 3 e to the power negative 3x minus integrate this will be e to the power negative 3x over negative 3, and we already have negative 3 in the denominator, so negative 3 will become positive 9, and then with the same limits, 1, 0. So I will expand the brackets for this part to make it simpler. So negative 8 over 3x squared e to the power negative 3x, and then positive negative become negative, and then 16 over 3 times 1 over 0 would be 16 over 9, x e to the power negative 3x. And again, positive negative become negative will be negative 16 over 3 times 9 is 27, e to the power negative 3x. And then with the limits, 1, 0. So now if we substitute the limits in, so substitute in 1 would be negative 8 over 3 times 1, and then e to the power negative 3 times 1, which is just negative 3. And then minus 16 over 9 times 1 is the same, and then e to the power negative 3 times 1 is just negative 3. And then minus 16 over 27, e to the power negative 3 times 1, which is again negative 3. And then minus, so substitute in 0. 0 times anything is 0, so just 0 for the first term. And anything times 0 will also be 0, so 0 for the second term. And then for the last one, it's minus 16 over 27. E to the power 0 is 1, so just negative 16 over 27. So now if we simplify this, so for the first half, I will just minus those numbers because they're all in terms of e to the power negative 3. So I will just do negative 8 over 3 minus 16 over 9 minus 16 over 27. So that will give us negative 136 over 27 e to the power negative 3. And then negative make it positive, that would be plus 16 over 27. So if we write in the same order as what the question asked, that would be 16 over 27 minus 136 over 27 e to the power negative 3. So in this case, A would be 16 over 27. And then B would be negative 136 over 27. And then e to the power negative 3, just e to the power negative 3. Let's have a look at question 7. Figure 2 shows a cylindrical tank of height 1.5 meters. Initially, the tank is full of water, so the water starts to leak from a small hole at a point L in the side of the tank. So, which is point L here. Okay. While the tank is leaking, the depth h meters of the water in the tank is modeled by the differential equation dH over dt equal to negative 0.12 e to the power negative 0.2 t. So where t hours is the time after the leak starts. So be careful with all the units. So t is in hours and h is in meters. And then using the model, A show that h equal to A e to the power negative 0.2 t plus B, where A, B are constants to be found. Okay, so for part A, we just have to integrate dH over dt equal to negative 0.12 e to the power negative 0.2 t. So for this one, we don't have to use separation of variable because the expression on the right-hand side is just in terms of t. So there's no h in it. So we don't need to do separation of variable. We just have to integrate straight away. So h is just the integral of negative 0.12 e to the power negative 0.2 t dt. So that means h is equal to negative 0.12 is the coefficients, they're the same. And then since this is just a linear expression, so just e to the power negative 0.2 t, and then divide by the coefficient of t, which is negative 0.2 plus c. So simplify that, h equal to negative over negative cancelled, and then 0.12 divided by 0.2 is equal to 3 over 5. So h equal to 3 over 5 e to the power negative 0.2 t plus c. And now we need to find out the value of C. It says initially the tank is full of water. So that means when T equal to 0, so the cylindrical tank of a height 1.5 meters. So if it's full of water, that means the height of the water should be 1.5 meters. So H equal to 1.5. So then substitute in h equal to 1.5 and then t equal to 0. So that would be 1.5 equal to 3 over 5. And then e to the power 0 is just 1 plus c. So c is just equal to 1.5 minus 3 over 5, which is equal to 0.9. So then h equal to 3 over 5, which is 0.6. Let me just change it all into decimal. So 0.6 e to the power negative 0.2 t, and then plus c, which is 0.9. Then that'll be the final answer for part A. It's only 3 marks. Okay, part B. Find the time taken for the depth of water to decrease to 1.2 meter. Give your answer in hours and minutes to the nearest minute. So for part B, we want to work out time when t which is t. So when the height become 1.2 meter. So we just let h equal to 1.2. So 1.2 equal to 0.6 e to the power negative 0.2 t plus 0.9. So minus 0.9 for both sides, that would be 0.3 equal to 0.6 e to the power negative 0.2 t. And then divide by 0.6. So 0.3 divided by 0.6 is just equal to 1/2. So 1/2 equal to e to the power negative 0.2 t. So that means negative 0.2 t is just equal to ln of 1/2. So, and then 0.2 t should be the same as ln 2 because ln 1/2 is negative of ln 2. And then, so t is just equal to, so 5 ln 2. So because divided by 0.2, 1 over 0.2 is equal to 5. So 5 times by ln 2, put in the calculator, we have t is equal to 3.46573. And then the units would be hours. But be careful about what they're asking you. So give you answer in hours and minutes to the nearest minute. So then that should be 3 hours. And then we need to change 0.46573 hours into minutes. So it comes by 60 for 0.46573. So that'll be 27.94. And they want to the nearest minute. So 27.94 is just 28 minutes. So then that will be the final answer for part B. So that's another 3 marks. And then part C, in the long term, the water level in the tank falls to the same height as the hole. So part C, find according to the model, the height of the hole from the bottom of the tank. So basically, it's just asking you what's the limiting height. So if we let t goes into infinity, so that means either part of negative 0.2t will go to 0. Because either part negative 0.2t will goes something like this, a diagram. So as t get bigger, it'll get smaller and smaller, eventually turns to 0. So which means h should turns into 0.6 times 0 just 0. So it just plus 0.9 is just 0.9. So that means the height of the hole from the bottom of the tank should be 0.9 meters.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.